With the wheel drivetrains in place, I'm now thinking of the drivetrain for the claw arm. To start that, I've placed 4 bearing flats, and you can see the location of those. I've now added 2 84-tooth gears, and again some shaft collars. Now just be careful how you align those gears. They're not symmetrical. I'm just highlighting that for you now. Make sure you set up those gears correctly. Also keep in mind to add that angle constraint so that the gears and the shaft drive each other. Next thing we want to do are add these smaller gears. These are the gears that will be driving those larger 84-tooth, and these are 12-teeth gears. There's a spacer, a gear, and then a shaft collar. And again, that's a 3-inch drive shaft that's in there. Let's see how those move. Well, that looks pretty good. Everything's moving, and the bottom's moving, but they're not moving together. So we need to be able to fix that. I've already aligned the gear teeth just as we did with the wheels. And I have a constraint here that's suppressed. So I'm going to unsuppress mate 7 in my case. Take the check mark off. That puts the gears correctly, or the gear teeth correctly aligned. Now I'm going to go up into my constraint and make sure that I choose the rotation motion. So the motion tab, select the circular face on the small 12-tooth gear, and because I selected the 84-tooth gear first, I key in 84 divided by 12, and that gives me the correct ratio. And I have to select the reverse solution. Of course, the gear can't move because that constraint is no longer suppressed. So I'm going to go into mate 7 and suppress that again. So with that constraint suppressed, those gears can now move correctly. And there we see that. As I rotate one gear, we can see that this smaller gear is rotating as well. And of course, the small gear will rotate 7 times for 1 revolution of the large gear. To drive that small gear, I need to insert a motor. So the motor will be driving that drive shaft, which will eventually drive the arm and the claw. I'm going to put in one of 2 motors, and it's the one with coupler that I'm selecting. To constrain the motor, I'm going to start with the motor and the drive shaft. Let's rotate that around so we can see that. There are 3 areas. One is the coupler, and the other 2 are threaded holes. So we'll start with the constraint and the center line. And we can go to the bearing flat and find the center line on that as well. And that will align the motor to the center line of the shaft. So apply that. And probably cancel it so I can drag that motor away. Be easier for me to apply the other constraints. Rotate it around. I can now add the 2 more constraints that are required to fix that motor in the correct location. Center line on the motor, center line on the bearing flat. Now I'll apply that. Then we want to use the mate constraint from one face to a face on the motor, making sure I select the correct face. And there we are. So the motor is now correctly located on that vertical support. With the drivetrain and the motor now in place, I've gone ahead and added the bearing pop rivets. There's a shaft collar and 2 pop rivets on the top, and then 2 more and a shaft collar in the bottom. And on this side, shaft collar, a couple of rivets. There's only 1 bearing pop rivet on the bottom bearing flat. That's because the shaft to the motor goes through 1. And then I've added a 6x32 by half-inch long screw and a 6x32 quarter-inch long screw. I also want to turn off the visibility of those work planes, so I simply go to View, Object Visibility, and select Work Features.